In this video, I'm going to be discussing how to graph linear, absolute value, and systems of equations. To graph a linear inequality, you would have the graph that is very similar to the y equals mx plus b. You would still graph it the very same way. So you're going to start at -3 and you're going to put a dot. And then the slope in this case is going to be 1, which means from this dot you're going to go up 1 over 1, up 1 over 1, and draw a line. However, this inequality does not have a line underneath. It is just less than, which means it becomes dotted. So please note that if there's not a line underneath, if it's not equal to it, then it's going to become a dotted line. And now all of the y values are less than this line, which is why you should shade everything below the line. If it is an absolute value function, which we just discussed in a previous video on how to graph, this is inside the absolute value, which means it moved it left and right. It is a horizontal translation. Horizontal translations are the opposite sign. So since that's a -3, that's why we moved it to the right 3. And then we were to graph. Again, there is not a line underneath. So therefore, it does not include the line. So therefore, again, it should be dotted, because it does not include the inequality. And in this case, all of the y values are greater than this graph. So that's why you would shade above it, because it's everything greater than the graph. This is another translation. This is a horizontal translation, and this is a vertical translation. So I know that it is going to look like a V. It is going to go up 4, but the +1 means I actually go to the left 1. It is, let's see, it does include the line because it has a line underneath, so therefore it is going to be a solid V. It is not going to be dotted. And we are shading everything below this graph because all of the y values are less than this graph. And so you would shade everything below this line. Would be shaded. You also can graph compound inequalities. Now, in a previous video, we discussed when there was no slope, it was just y equals a number, it became a horizontal line. Same thing applies here. So in this case, you're going from -4 up to 3 on the y-axis. So that's why you go from -4 up to 3, except that should be a solid line. Why should that be solid? Because there's a line underneath. That should be a solid line. And the bottom should be a dotted line because there is no line underneath. And the y value is contained in between these numbers, which is why everything in between is shaded. You also can graph systems of inequalities. So for example, if we were to graph this line, you go up to 5, and then the slope is -2, which means you go down 2 and over 1, down 2 over 1. The line is solid because you have a line underneath the inequality. You are shading everything below this line because it says all the y values are less than this line. So you should be shading everything below. This graph, you start at -2. The slope is 1. So you'll go up 1 over 1, up 1 over 1. And this says all the y values are greater than this line. So you should be shading everything above the line. It does not have a line underneath. This line right here is not underneath y, and that's why it should be dotted, which it is. So what the answer ends up being is where these two shades overlap, which means everything that is inside this shading that has been overlapped by the two equations or the two inequalities is going to be correct. Meaning, if you were to choose a coordinate point anywhere in this overlap, for example, 0, 0 is inside this overlap. That means if you were to plug in 0, 0 into this inequality, y is 0, x is 0, you will get 0 is less than or equal to 5. That is a true statement. And if you were to plug in 0 here as well, you would get 0 is greater than -2. And 0 is greater than -2, which is a true statement. So any coordinate point that is inside this overlapping region, this coordinate point, 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 will be true statements for both inequalities. Real world connection. Suppose the student council has asked you to form a committee to run a bake sale. The committee needs between 7 and 10 members made up of juniors and seniors. The number of seniors should be greater than the number of juniors. Well, if we say that Y represents seniors, and we can say X represents juniors. So first, we know that seniors should be greater than the number of juniors, so we know it's going to be Y is greater than X. We can go ahead and graph that. It starts at 0, 0, and the slope is 1, so you go up 1 over 1, up 1 over 1, and it is going to be a dotted line because the number of seniors does not equal the number of juniors. It is going to be greater than the number of juniors. We also know that you can't have less than 7, which means if you add the number of seniors and juniors together, it has to be greater than 7. And at the same time, if you were to add the juniors and seniors together, it can't exceed 10. It has to be greater than 7, but it has to be less than 10. So therefore, if I was to graph these equations, I'm going to represent this. I'm going to represent this to be a different color, and I'm going to represent this to be a different color as well. Okay. So first, we know that Y is greater than X is going to be shaded above because all of the Y values are greater than this line. Now for the pink, we know that it starts at 7. Oops. We know that it starts at 7 and the slope is -1, so you go down 1 over 1, and it is a solid line because you can have 7 members, and it does say that Y is greater than this line, so therefore you would shade everything greater than this line. And last, this changed. And last, to graph this, you start at 10, and it's going to be down 1 over 1, and it is going to be a solid line, and it's going to be everything is less than that number, or less than this graph, so you're shading everything below. So therefore, the amount of shading that overlaps is this very, very, very narrow passage. It stops here at the dotted line, and it's everything in between. So any coordinate point that rests in between here is going to be what you can make up of the number of juniors and seniors.